To make the player move, we need to write specific logic. So far we've been using things that Unity already provides us, like components, we have the directional light, we have our camera, we've made some simple meshes and made materials, but for movement we need to write logic for this. So we need to make a script. First of all, we're going to the project window in the assets panel. We're going to right click, select create and C# script. We're going to rename the script to player. Okay, and after that we're going to wait for Unity to compile this newly added script just to make sure everything is okay. So this happens every time you create a new script or edit it, so you have to wait just a little bit before it can be properly used. Now we're going to the main camera game object and we're going to rename it to player. Okay, let's collapse these other components, and now it's still going to behave a camera, don't worry, we just renamed it, but we're going to add another logic to it. We're going to apply this script to our player game object. So we click here and we can drag here, or we can drag to the player game object. Both work the same. Okay, so as we put it, we now have a player script component. Okay, so we can, whatever we write in the script is going to be executed in the player game object. So now we're going to double click the player, and then we wait for MonoDevelop to open. It's a software for writing code that already comes with Unity. It works well. Okay, the latest versions are better than ever, and it's free, it's open source. You don't have to worry about downloading any other tools, but of course if you want to use, you can. But this works just fine for us. Now, this script contains a few lines in here, and if you're not used to writing code, so let's take a very quick look here. These first two are used for adding namespaces to this file, so we are able to use some classes and properties and methods. Okay, it's basically allow us to use things that are not written here. This portion of code is the definition of the player class, is the definition of what the script is going to do and how it's going to behave, how it's going to make our player behave. Inside this class, we already come with the definition of two methods. And a method is a sequence of operations that are going to be executed once the method is called. So we have two. We have start and we have update. As you can see in this comment here, it's basically some instructions. The start method is used in the initialization. Okay, this is called whenever our component is ready to be used. So it's a very good thing to have here. And we also have an update method, which is called on every frame. So every time your game is processed by your mobile phone, your smart TV, on your computer, then the update method is going to be called. And this is going to help us a lot on making the player move. Okay, let's learn how to do this. First of all, we're going to define a variable here. We're going to type public float speed equals to 5.5f, and then a semicolon. So what did we do here? We declared a variable called speed. Okay, it's a position in memory that is going to store something for us. We say that this thing that is going to be stored is going to be a floating point number, so it's a number that contains a decimal part. When we say that it's public, it means it can be accessed on other places, like on other objects, on other classes, and well, in the Unity editor, which is the purpose of doing this. You're going to see this soon. When we use the equal sign, we're not making a comparison, we're making an assignment. So we're going to get this value here and already assigned it to the speed variable. Okay, and the semicolon is just to finish this statement. And 5.5f, it just means that it is a floating point number that is 5.5. Okay, now we're going to save the script by hitting Command S or Control S, or going to File and pressing Save. We go back to Unity. Now we wait for the compilation to complete, and if you look at the player game object and look at the script, you're going to see that now there's a speed field in here. And the beauty of this is that we can change these values to whatever we want without having to recompile the code, without having to wait. So this is perfect for designing a game. Okay, you can change things pretty quickly, and if you just want a game designer or a friend to tune your game, your friend doesn't even need to learn how to code. You can just open the Unity editor and change these values here. Okay, so we set a speed variable, but our player is still not moving. How do we make this movement? We need to go to the player class, and we're going to deal with the update method. So here, this is what we're going to do. Transform.position plus equals speed multiplied by vector3.forward multiplied by time.delta time. So what did we just write here? Okay, first of all, when we type transform, we are accessing the transform component that is attached to this game object. Okay, so when we do this, we are accessing this component. We are going here. When we say dot position, it means we're going to access the position field in this transform component. So we're going to deal with this. Okay, that is 0, 1, minus 10 right now. When we use plus equals, it means we're going to increment whatever is saved here. So we're going to increase a certain value to it. And this value is speed. Okay, it's going to be 5.5 multiplied by vector3.forward. And in this case, vector3.forward, if you put your mouse here, you can see that it is a shorthand for writing the vector 0, 0, 1. So that is an arrow that is going to point forwards, which is where the player is going to move to. Okay, and when we multiply that vector by speed, we're going to scale that arrow. Okay, we're going to make the player move faster or slower. And when we multiply by time.delta time, we ensure that the player is going to move at more or less the same speed despite of the capabilities of the device it's running. So if you're going to run this game on a slow device or on a fast device, it's going to be, one is going to have more frames per second, of course, but the movement per frame, once you see it over time, it's going to look the same on both devices. Okay, you do this to make sure that a game in a slow device is not going to be easier than a game in a fast device. So if you save this, go to Unity and wait for the compilation to complete, and you hit the play button, you can now see the player moving forward, okay, which is great. Right, we already have made a very simple script. Here we define the speed variable. If we want, we can change that variable at runtime to see how slow or how fast it's going to be. Okay, so if I change to 1, it's now much slower than before. Okay, it's very, very slow. If I change to a negative value even, so if you want to give a very quick test, it's going to move backwards. Okay, but if we leave it positive, it's just go to the forward direction. Okay, and now to give a little effect that we are walking to the front, it's interesting to make the player to move a little bit in whatever position it is. Okay, so it's kind of making the player to simulate that walking effect. So we're going to work on this effect in the next video. To create a walking effect, we have to separate the player logic from the camera logic. So this is what we're going to do. We're going to right click anywhere and select create empty, and we're going to name this game object as player. Okay, let's move it up. So we have two players now. We have this player and we have this one. This here, the one that we had before, is going to be renamed as player camera. Okay, now we need to ensure that player and player camera are in the same position. So we can go to the player camera, we can copy the transform component, clicking here, and in player we can go to this cog and then paste component values. Okay, so we ensure that player and player camera are both in the same position. We do this because we're going to put the player camera inside the player, and now we need to move this player script to the player. Okay, so we're going to click here, copy component, on player, click here, paste component as new, and we can remove this player component from here. Okay, so now if we hit the play button, you see that the game works exactly the same. Okay, we're still moving forward, the player is still moving, but we're going now to write a script for the player camera, okay, because we're going to make it to move up and down. So in the assets panel, we're going to right click, select create, C# script, and name this player camera. Now we wait for this script to be loaded, and once it is, we're going to move it to the player camera here. Okay, so we're going to grab it, drop it here, and double click so it's going to open. So the trick that we're going to use here is we're going to use basic trigonometry to make the player move up and down. So in the update method, this is what we're going to type. Transform.position is going to be a new vector3. Okay, so we've got this. And better yet, instead of using transform.position, we're going to use transform.local position. And why is this? If you look here, the player camera right now is on 0. What we want to do in the vertical position is we're going to do this. Okay, we're going to increase and decrease the vertical value. And notice that this is going to work like this when we use the local position, independent of where the player is. Because the player is going to move forward, the player is going to jump. So if we do this in only one script, we might screw up the jumping logic. So that's why we separate that and we use local positioning for the player camera. Okay, so if we come here in the update method, we have transform.localPosition equals to a new vector 3. So we are building a new vector information. It requires three parameters, x, y, and z. So we need to set these numbers. Okay, so x is going to be exactly what was before. We don't deal with x. So we type transform.localPosition.x. The same thing for z, which needs to be transform.localPosition.z. Now the y value is going to be different. This is what we're going to type: mathf.cos for the cosine operation, and here we're going to pass transform.position. Okay, it's not local position this time, it's just position.x. Okay, so what is happening here? Actually, .z. Okay, so the local position of the player camera on X and on Z, it's going to leave to be untouched. Okay, we're not going to change that because we just want to make it move in the vertical axis like this. So the Y value that we put here as the second parameter is going to be based in the world position of Z, because even though we are not changing the X or the Z position locally, we are changing it globally because the player is dragging the player camera. And we're going to change the height based on where the player is in the depth axis. Okay, it's a little trick that is very common in some space shooting games. Okay, so we're going to save this. We're going now back to Unity. Let's wait for this compilation to complete, and we're going to test this out. So after it finishes, let's hit the play button, and our player is moving and the head is moving up and down. Okay, so right now it's a bit too strong, so we have to tune this. Okay, this effect is working just as expected, but we need to change a few things. So we can type here public float movement amplitude, and let's set that as 0.1f. Okay, and we need to define a public float movement frequency, and let's define that as 2f for now. We're going to tune this later. So here, where we call the cosine operation, we're going to multiply all of this by movement amplitude. So it's going to define the maximum height and the minimum height that the player is going to reach, okay, by doing this. And also we have to set the frequency. The frequency is going to be here. Okay, we multiply that by movement frequency. It's how frequently the player is going, the camera is going to change in the vertical axis. So we're going to set this as 1. So let's save this. Now we go back to Unity. Let's wait for this compilation to complete. And after it is done, we're going to hit the play button. And once we do this, now the camera is working much smoother than before, okay? But we have one problem here. The player's camera position is fixed on 0, okay? So if we want to change this position, we can actually just go to the player game object and move it to the desired position. So I can use 1.76, for example, for a relatively tall person. Now we hit the play button and our person is moving. If we want to change and see how things should look better, we can just go to the player camera and change movement amplitude and movement frequency. I think the frequency should be higher. So if we put 2, it's a bit too much. Yeah, I used 21. So if I put 2, the player is a bit faster. 2.5, it actually gives that feeling that we are running. Okay, so 2.25 I think is the best value. As for amplitude, I think this one is fine, because if you use too much, it would just move too much. Okay, it is a bit too harsh. So we can use 0.1 here and 2.25 here. So we're going to save these values. Let's memorize them, because once we stop the scene, they're lost. So frequency is 2.25 and amplitude is 0. I think was 2. I'm not entirely sure, but well, we just play the game, and yeah, 0.2 is just too much. I'm going to leave 0.1. Okay, so let's change that back to 0.1. So now we have work on the full movement logic for the player. Now what we have to do is to make the player to be able to jump and avoid these obstacles. jump, we're going to apply some basic physics to it. So in the player, we need to add two things. We're going to click on Add Component, and we're going to search for Box Collider. Okay, this thing here, this box collider, is an invisible box that is going to be used for processing collision and overlap. So that's a virtual area that is used for, well, calculating any collisions. Okay, so now that we have this, we need to change its size on the Y variable so it touches the floor. So let's change that to 2 and set the center to -1. Yeah, that's a bit too much. So let's use 1.76 on the size, and we're going to change Y to be barely above the floor. Okay, so it's going to look like this. Okay, and we put it as close as possible to the floor, so it's more or less the position where this is going to stay. Now we're going to click on Add Component, and we're going to search for the rigid body. We're going to click here, and it's going to be right here. Okay, so the rigid body is what is used for actually applying physics in the game. Okay, so we enable this use gravity property here, and in constraints we're going to set a few things. We want to constrain the position of this player on X and on Y because it only moves on Z, and we want to freeze the rotation on X and Z. Okay, actually we can use Y as well, so the physics is not going to be weird. Okay, so if we hit the play button, our player is now moving, but now we are hitting the obstacle, okay, which is just fine. It's working as expected, because what is going to happen when we collide with this obstacle is we're going to kind of trip, we're going to lose some speed, and then we're going to keep moving forward. The obstacle is going to be removed. Okay, but now that we have this, we can actually work on making the player jump. Okay, so what we have to do is we have to go to our script here, and in the update method we need to check if we pressed the Google Cardboard button. Okay, so let's keep things tidy. I'm going to add a comment here that is going to say move the player forward. Okay, actually this is the player camera. Let's go to the player script. Okay, and here in the update method we put move the player forward. Great. Now we want to write the logic for make the player jump. So make the player jump. And what we want to do here is we want to check if you press the cardboard button. We're going to type if, we open and close parentheses and open and close curly braces. This is a conditional block. We're going to ask a question in these parentheses, and if this question is true, then whatever we put in curly braces is going to be executed. Okay, so the question that we're going to add here is GVR viewer actually dot instance dot triggered. This property is going to return what we call a Boolean value. It's either true or false. This is going to be true in the exact frame you press the cardboard button or you just touch the screen. Okay, and then it's going to turn false until you press again. Since we are developing in a computer, we want to add something to help us testing this jumping logic. So we can add the spacebar button. So we're going to add an OR operator here by using two vertical bars, and we're going to add input.get key down, and we're going to pass the string space as a parameter. So if we press the space button, we're going to make the player jump. Okay, so when we do this, now we want to set the jumping force. So let's make this a variable here, public float jumping force, and let's set that as 450F. I'm not sure what value we're going to use, but well, let's put it here. And here we need to access the rigid body of the player and apply that force upwards. To do this, we're going to simply type get component, okay, or you can type this.get component, is the same thing, it's implicit. We use the lesser than sign and we add here rigid body. Now greater than sign to close this scope here. We open and close parentheses, and then we use a dot to call a method or access a variable, and we're going to call the method add force. We open and close parentheses, and here we're going to pass a parameter. This parameter is going to be vector3.up, which is an arrow that points up, multiplied by jumping force. Okay, so now we're going to save this. We're going to Unity. Let's wait for this compilation to complete. And once it is complete, we are now going to hit the play button. Okay, and we have a jumping force there. And if we press space, okay, our player is jumping too little. Okay, almost like it isn't jumping. So let's change that jumping force to 1000. And let's try that again. We hit the play button. We hit space and still not moving too much. And this is actually not happening because we added a constraint in the vertical position. Okay, we shouldn't do that, otherwise our player is not going to move. Let's try that again. Now if we press space, we move too much upwards. Okay, so that was a big jump. So 1,000 is too much. Let's change that to 200. Let's try again. We hit the play button and we click. This time we jump a bit shorter, but that's not enough. So yeah, probably the 450 that we said at the beginning was enough. Okay, once again we hit the play button and well, this works fine. Okay, it's something that we have to tune. We can even tune live. So if you use 350 and we click, I think it works pretty decently. So let's use 350 here. And notice that I just used a few seconds until I found some problems and then defined the proper values. So Unity requires a lot of that. You just have to experiment. Okay, try things and see if they work fine. And there is a funny thing that can happen in here, because if you keep pressing space, you'll be propelled upwards all the time. So we have to add a cooldown here. So we can come here and make a public float jumping cooldown, and we can set that to be 0.6f. So we have to wait 600 milliseconds until we jump again. And now we add a private float jumping timer equals to 0f. So this is going to be used to tell us if it's the right moment for the jump. In the update method here, we are going to decrease the jumping timer. So we type in jumping timer minus equals time.delta time. So it's going to decrease. And when we trigger the button, we need to check if the timer is lesser than 0, so we are allowed to jump. So if jumping timer is lesser or equal than 0f, we're going to do this, and also we're going to type jumping timer equals to jumping cooldown. So we reset the timer and we have to wait 600 milliseconds until we jump again. So it's a very simple way to constrain how quickly the player can jump again. Alright, so we press the play button here. Our player is moving. If we press space, we have to wait for 600 milliseconds to pass, but that is not enough. So let's change that to 1.5. I press the space button, and apparently this is enough. Yes, 1.5. We simply save this here, and we can test it again. We hit the play button, we are walking, we press space, and we have to jump in the right moment, and there we go. We jumped over the obstacle, which is exactly what we wanted to happen. Okay, so now that we have this, we need to be able to collide with the obstacles, and we need to change how the player is going to move by adding some acceleration logic, because the obstacles are going to slow us down. Let's work on this in the next video.